Let's do this together. Okay, you have y equals x to the fourth minus 4x cubed. I'm looking for an open interval where the graph is both concave up and decreasing. Let's think about this. Concave up means what? F, what is positive? The second derivative. Second derivative is positive. Decreasing is what? The first derivative is negative, okay? So this is talking about the second derivative. This is talking about the first derivative. So in order to solve A, you need to consider the sign of both the first derivative and the second derivative, okay? And then after that, you have to find the inflection points and extrema. Let's think about the solution. You differentiate once. Y prime gives you 4x cubed minus 12x squared. And that can, since they both have x squared as a factor, let's factor this.
0, 4, 2.
Actually, you have, then you can factor the 4 out also. So if I factor the 4x squared, you end up with x minus 3. All right, we need to know the sign of y prime. How do you know the sign of a function over some intervals? Well, first figure out when it's equal to 0. When is this equal to 0?
0 and 3.
0 and 3. If x is 0, this gives you 0. If x is 3, this becomes 0. So those are the points where y prime is 0. Once you identify the points where y prime is 0, then you want to find the points where points in between for each of these intervals. These are called test points. Your test points should be small and simple. Simplest you can get, also the smallest you can get. All right, so you get -1 plugged back in here. This is always positive, so one way to quickly determine the sign is just ignore the parts that's always positive. Just pay attention to the parts that could change sign. And you see, x minus 3, if you plug in -1, -1 minus 3 is negative, so it's negative here. If you plug in 1, that's also negative, right? And if you plug in 4, 4 minus 3 is positive. Okay. So we know that here or there it's decreasing, but here the function is increasing. This is the value of y prime. Let's do the same thing for y double prime. Differentiate again, you get 12x squared minus 24x, which gives you 12x times x minus 2 as the factored form. And you have 0 and 2 as the points where y double prime is 0. Let's pick test points here, 1, -1, and 3. And again, this time you have to consider both again. So if you plug in -1, -1 times -3, that's positive. So y double prime is positive here. If you plug in 1, 1 times -1, that's negative. If you plug in 3, that will give you positive. That's y double prime. Okay. Now let's first pick out the points, where intervals where it's concave up. So it's here from -infinity to 0 is concave up, right? And also 2 to infinity, it's concave up. All right. Now here, -infinity to 0 is what? Decreasing, right? Here, -infinity to 0 is concave up, so it does fit this description, right? Concave up and decreasing. So that's one possible answer. A, -infinity to 0 is one of the intervals where it's both concave up and decreasing. However, there's another interval that's a little harder to think. Can you figure it out? Can you look at this diagram and figure out the other interval where the graph is concave up and also decreasing? Well, 2 to infinity is concave up, but it's increasing from 3. So you can't say 2 to infinity.
Isn't 3 decreasing?
Huh?
Isn't 3 decreasing? Or after 3?
Up till 3 it's decreasing. From until 3 it's decreasing. So how do you write this? I mean, you're getting there, right? Here it's concave up, and up till you reach 3 it's decreasing. So what can you say? 2 to 3, right? If you think about the interval 2 to 3 in here, this interval is part of this concave up interval, so this is definitely concave up from 2 to 3. And 2 to 3 fits in here, which is part of this interval where the function is decreasing, right? So it's both decreasing and concave up between 2 to 3. So you actually have two intervals. Yes?
I'm confused. How can concave up and decrease? Doesn't concave up just go like this, which means increases, shows decreasing?
Okay, so think about something that's, so your question is, how can you have something that's concave up and decreasing? Well, first think about the graph that is decreasing. This is the graph, right?
Yeah.
Okay, now again, think of this like a rubber band, rubber rod, and you want to make that concave up. What do? You push from above, right? If you push from above, what shape does it become?
Go down.
It becomes that, right?
I
So that,
thought it was the other way around. I thought concave up means you push up, so I thought I was confused.
no, you push from above. You push from above, okay? If you push from above, this will be concave up and going down. What's concave down and going down? What's a function what's a graph that's concave down and decreasing? If you have concave down and decreasing, this is decreasing, and you can push from below, and it's going to bend like that, right? That will be concave down and decreasing. That's concave up and decreasing. You can also have concave up and increasing, concave up and concave down and decreasing. All those 4 cases are possible. So actually, if you think about this smiley face of concave up, any portion of this curve here is concave up. Okay? So if you divide it into 2 parts, this right side is concave up and increasing. This left side is concave up and decreasing. That's another way to think about it. All right. Now, can you figure out the points of inflection? What's an inflection point again?
One of the graph.
Changes.
It's a point on the graph where the concavity changes, right? So where does the concavity change? 0 and 2, right? Before 0 it's concave up, after 0 it's concave down, before 2 it's concave down, after 2 it's concave up. So there are definitely changes in concavity both before and after 0 and 2. So therefore, to answer part B, you have to plug in 0 into the original function, which gives you 0. 0, 0 is 1 point of inflection. And when x is equal to 2, you can plug it in here, and that gives you 32, 16, so it would be negative 16. Okay? So if you plug in 2, you can get negative 16. Okay? Again, I want to stress that point of inflection and also extrema are points on the graph. So when you put your answers, you should actually put x and y coordinates. You actually need the coordinates, entire coordinates. Sometimes the question could be asked in the following. At what x values does the inflection points have? In that case, you only need to report 0 and 2, but if you're being asked the inflection points itself, you have to plug them back into the original function to give the coordinates of the graph. Okay, now part C, let's find the extrema. We learned how to use the first derivative test, right? This means it's decreasing and decreasing and then increasing. Do you see any relative maximum here? To be relative maximum, what should happen? It should be increasing and decreasing, right? Do you see anything like that? No. Do you see any relative minimum?
Yes.
It has to be decreasing and going up. Okay, so what's the one?
0.
0, it just continues to go down and down, so it's not a relative.
Sure.
Yeah. So the nice thing about 0 is, the interesting thing about 0 is that here, 0 is one of the critical numbers. Okay, the critical numbers are points where y prime is 0 or undefined. So at 0 and 3, they both give you y prime 0. However, this one is not one of the relative max nor a relative minimum because it just continues to go down. It just briefly stops and just continues to go down. Okay? And at 3, there's a change in increasing, decreasing, and it's actually going down and going up. So there's a relative minimum at 3 comma
Negative 27.
negative 27. Thank you.